Okay, so let's go ahead and work this, this vector example from the lecture. And so just to kind of remind you what the problem is here, we have two vectors. Vector A, which has a length of 10 meters, and it's an angle of 15 degrees from the x-axis. So we've drawn that on this diagram over here, where here's our y-axis, and there's our x-axis. And vector B has a length of 7 meters, and it's at an angle of minus 45 degrees, or 45 degrees below the x-axis. And we want to know what is the vector we get when we add those together. We'll just call that vector C. And so remember, if we're adding vectors, we have to add the components. Okay? And so remember that, so we need to add the components then. So if we're trying to find the x component of vector C, we need to add the x components of vector A and vector B. Okay, so now we need to figure out what are the x and y components. And so remember our equations for the x and y components. If we're dealing with the x component, we use the sign. So the x component of vector A, sorry, did I say sine? I meant cosine of theta. And if we don't want to know what the y component is, we multiply it by the sine of theta. And remember, this setup here only works if we're measuring our angle from the x-axis. Okay? So if we have to, if we're given a different set of angles, then we have to make sure that we set up our trig in the right way. Okay. So if we do this, then the x component of vector A is the length of vector A, 10, times the cosine of its angle with the x-axis, which is 15 degrees. And the x component of vector B is its length, 7 meters, times the cosine of its angle with the x-axis. And this is where it's important to keep this minus sign, okay? So when you do this calculation here, making sure your calculator's in degree mode, what we get, 10 times cosine of 15, then we go ahead and add 7 times the cosine of minus 45, we get 14.6 meters. Okay, so there's our x component of our added vector. But that's just half the problem. We need to know what the y component of this vector is. Okay, and that's the y component of A plus the y component of B. Okay? And so remember, with the y component, we're dealing with the sine of that angle now. So the y component of vector A is A, which is 10, times the sine of its angle, which is 15 degrees. And we have to add that to the y component of vector B, which is its length, 7 meters, times the sine of its angle with the x-axis, which is minus 45. Okay, so we do this calculation. It's 10 times the sine of 15 plus 7 times the sine of minus 45. And we get the result minus 2.36 meters. Okay, so there's our x component, there's our y component. Now let's go ahead and erase all this because we're going to need more space. So let's just keep those x and y components up here. So we have the result that Cx is 14.6 and Cy is minus 2.36. So let's go ahead and erase the rest of this stuff here. Now, this could be your answer here, but remember the question really is what is the magnitude and direction? So we found the components, so now we just need to figure out what is the magnitude and direction of our vector. Okay? Well, remember, if we have an x and a y component like this, so here's our vector c. Well, it has an x component of 14.6. Okay, so there's its x component. Its y component is negative 2.36. And we want to know what the full magnitude is of c. So that's where we use the Pythagorean theorem. The magnitude of c is the square root of the x component squared plus the y component squared. Okay, and that's the square root of 14.6 squared plus negative 2.36 squared. And take the square root of that whole thing. And what you get when you do this arithmetic here, you get 14.8 meters. So there's our magnitude. That's the length of our vector then. Now we just need the direction. And that's where our arctangent equation comes in. So remember, the angle it makes with the x-axis is the arctangent of the y component divided by the x component. Okay? And so that's the arctangent of negative 2.36 divided by 14.6. Okay, so we plugged in the y and the x components there. And when you solve that, you take this, divide it by that, and then take the inverse tangent of that. And the number you get is negative 9.2 degrees. So there's our direction. Now what that means is it's a 9.2 degree angle, and it's below the x-axis. Okay? And so that's kind of what we expect when we look at this geometry here. We have a 14.6 x component, negative 2.36. So it points below, and this would be a 9.2 degree angle. Okay? Now we can try this graphically as well. Remember, the way we can add vectors graphically is we take our vector b and we put it on the tip of vector a. So that would be something like this. Something kind of like that. And then we draw a new vector from the origin to that point. And so that would be something like that. Okay? So that is our summed vector. So there's our problem then.